Okay, welcome Year 9. So we have a PowerPoint here on factorising. Quick look at the real reminders, probably not super relevant now, but nice to remember the good old days of the classroom. And our WALT for today is we are learning to factorise algebraic expressions. Now really quickly, okay, last lesson we had a look at expanding algebraic expressions. So we have a very quick warm up here to make sure that we can still do that from last lesson. So I'll give you guys a couple of minutes to have a go at that. If you can pause the video and I'll see you back here real soon. Okay, so welcome back. We're just going to run through these expansions very quickly, make sure that we, as I said, still remember how to do so. So what we're going to do is we're going to multiply the number out the front by every single term inside the brackets. So what that's going to look like, 5 times x. Okay, there's a plus in our question, so there's a plus here. And then we have the number out the front, which is 5 times our second number. We'll tidy that up a little bit, and I get 5x plus 5 times 3 is 15. And then the second one. So again, number out the front multiplied by both values inside the brackets, and I end up with 3b times minus 2b. So there's a subtract here, so I'll make sure I get my subtract in my answer. Number out the front, 3b times 7c. Matter of tidying that up once more. 3 times minus 2, so I'll deal with the numbers first, and I get minus 6. I have a b times another b, so I have b multiplied by itself 2 times, so I can simplify that to b squared. Take away, numbers first, 3 times 7, 21, b, c. Simple as that. Now the reason why expansion is a really good warm-up for today's lesson is because factorising, the new content today, is kind of like the partner or the pair of expanding. Just like multiplication and division are pairs, just like addition and subtraction are pairs, expansion and factorising are pairs themselves. Okay, so the new content for today, guys, we're looking at, as we said before, something called factorising. Now, the word factor, okay, that first part of that word should be very, very familiar to us, okay? We've seen factors before, and we've looked at it in terms of factors of different numbers, or two numbers that multiply together to give us an answer. So, for example, factors of 12 would be 2 and 6, because 2 times 6 equals 12. Also, 3 and 4 are factors of 12, because 3 times 4 is equal to 12. Nothing super new for us, but what we're looking at today is expanding our idea of factors to algebraic factors. So let's have a look at this second example here. It says expressions also have factors. For example, we can see here that we have 2 times bracket x plus 5 is equal to 2x plus 10. So it's very much the same idea. What are two numbers that multiply together to give us our answer? Well, 2 is a factor, and also x plus 5 is a factor. Now, the aim of factorising, the aim of today's lesson, is to write expressions as the product of 2 or more factors, okay? Just as with numbers, we can factorise 30 and write 30 is equal to 6 times 5, or 2 or more, 2 times 3 times 5. Now, as we said, we are going to expand that idea to algebraic expressions, and let's have a look at what that looks like. Factorising. It is the opposite procedure to expanding, okay? Just like, as we said before, we have multiplication and division, they're opposites. Addition and subtraction, they're opposites. We can expand going one way, okay, as we have arrows there, and then the opposite would be to turn our expanded form into factorized form with the brackets back in there. So our job today is to take our answer from an expansion and put the brackets back in. Might seem a little counterintuitive here, but it is important to note that sometimes factorizing is really, really powerful for solving equations, for answering particular types of questions, and making our lives easier when we have a big, yucky expression. To factorize, what we have to do is we have to find the highest common factor, okay? Should be, again, something that we've seen before in fractions and adding and subtraction. It's adding and subtracting fractions, I should say. In the example above, we can see that 2y and 6 have a common factor of 2, okay? So if we think about it, 2y can be... Okay, so first things first is we need to have a look at what our highest common factor could be. So, as we said before, we've seen highest common factors in our fractions, in our ratios, in simplifying problems from time to time, but here we are seeing them once more in our factorizing problems. Now, we do step things up a little bit with our factorizing problems because our highest common factor, okay, could be a number, variable, or a product of the two. So there's a little bit going on that we need to be on the lookout for any of these. So our first example, okay, we'll just run it through. We'll break it up in the slides to come, but step it through really quickly. We can see that we have a 2x and a 10, okay, and we're looking for a common factor. Now, the first one, the first term here, the 2x, well, the numbers involved is a 2 times an x, and then the factors involved in 10 would be 2 times 5. We can see that there's a common factor of 2 very easily, so a 2 goes out the front, and then the remaining factors go inside there, so only a number as the highest common factor. For the variable, for the next example, we can see, well, there's an x squared and a 5x, so there's no numbers here in the x term. Okay, the squared isn't a number. Okay, we're hopefully pretty comfortable with powers. Simply means that there is an x times an x. The 5x, so there's an x in both terms, which means the x is common, and we can put the x out the front, leaving the remaining terms, the second x, and then the 5 from the coefficient inside of our brackets. So the common factor goes out the front, and the leftover goes inside the brackets. Product of numbers and variables. Third one is probably the trickiest because we need to think about both the numbers, okay, and then the variables, okay. So a bit going on with these ones, but really quickly we can see it's just a combination of those two examples. 2x squared and 10x. Well, there's an x in both, so we would expect there to be an x as the common factor, but that is not the highest common factor. We need to think about the numbers as well. Like the first example, we would then have 2 times x, 2 times 5. Common factor is 2, so a 2 goes out the front. That's just a really quick sneak peek. Don't be intimidated. We're going to break all that down in the coming slides. Okay, so taking a really quick step back here, guys, and having a bit of a look at how do we actually calculate these highest common factors. Okay, maybe we need to have a bit of a refresher. Now, my favorite way is to write down a factor list, and then I can compare my lists of factors. So again, factor, just two numbers that multiply together to give me my answer. So if my answer is 20, two numbers that times together to give me 20 might be 4 and 5, might be 2 and 10. And then I need to do the same for my 35, my other number. So I think 7 and 5, and that's about all that comes to mind there. So what I now need to do is to compare my lists of numbers and see which one is the highest number that is common to both lists. And I can see that 5 is in this list and 5 is also in this list. It is the highest number that is in both lists. So therefore my HCF is equal to 5. That's all we have to do. Let's have a look at the next one. So the next one here is a little bit more involved, okay? It's one of those tricky ones that has both numbers and variables in it, so we do need to be on the lookout for that. Now, I prefer to do the numbers first, and then we'll do the variables in a second. So let's have a look at the factors of 18. So I can see that I've got 9 times 2 is 18. I've got 3 and 6, okay? Have a look at 24, so I've got 12 and 2. I've got 6 and 4, and that'll probably do me. compare those two lists, and so they both have 2 in them, but I can also see that they both have 6 in them. Now 6 is of course higher than 2, so 6 is going to be my highest common factor, or HCF is equal to. And of course there were some variables in our problem here, so we do need to think about those as well. I like the variables. I think they're easier because all we need to do, we don't need to know our number facts, we don't need to be too tricky about it, we just need to see which variables are in both terms. So 18A obviously has an A in it, 24AB also has an A in it, so there is an A that is common to both. B is not common in both, it is only in 24AB, so B is not common. Okay. Last but not least, let's have a really quick look at this one. So factors of 12, good, 4 and 3, 6 and 2, factors of 15, 5 and 3. Again, I'm comparing those lists, I'm looking for the highest common one, which looks like, oh, excuse me, 3. No 5 in that list. So I have my HCF is equal to 3. And again, this one has variables in it, so let's have a look. This one has an x, this one has x squared, so we can think about x squared again as being x times x. So there's almost like there's 2 x's in the x squared problem, but there is only one x that is in both. One x is common, okay, because 12x, there's only one x. Okay, so what we have here, guys, is a couple of you-dos. So I'm going to give you a chance to have a go at these problems yourself. If you can have a look, give yourselves about 2 minutes or so, see how you go calculating those highest common factors. You can come back after that short break and we'll compare our answers. I'll see you soon. Okay, so if you have unpaused the video and you're ready to have a look at some answers, let's have a very quick look. Now, this first one here was a little bit tricky, okay, because we also needed to think about the factors of 16 as being 16 and 1, as well as 8 and 2, 4 and 4, because some factors of 32, of course, 16 and 2, as well as some others. Now, hopefully we saw that 16 is the highest common factor there. So our HCF is equal to 16. Okay, this one here, so we have 16 being 8 and 2, 4 and 4. We probably don't need to include 4 twice, but I don't know, why not? 8 and 4, 2 and 12. I compare these two lists and I can see that 8 is common. I compare the variables A and AB and I can see that there is an A in both lists. So 8 was my largest number, A was in both lists, and I'm going to compare my last one over here. Okay, and I'm looking at 25x and 30, 5 and 5, 5 and 6, as well as 10 and 3, but not too stressed about that because I could already see that 5 was going to be my common factor there. Comparing the variables, so I have x and I have x squared. So again, okay, my HC, is my pen gone? Here it is, HCF. Oh, playing games, running out of ink. Okay, well my HCF is going to be 5x. There we go, got there eventually. Okay, so hopefully we're a little bit more confident with our highest common factors. Let's have a look at putting it all together now. So, factorising expressions. To factorise an expression, you first take the highest common factor, so the thing we've been working on calculating, outside the brackets. So the highest common factor goes outside the brackets. And then we divide each term by the highest common factor, and we leave the results in the brackets. Okay? So let's have a look at what that looks like when we piece it all together. So we have an example here. Okay, to starting here, we have 10x plus 15y, and we are looking at factorising that. We can see that the highest common factor is 5, and 5 is going to go outside the brackets. Now, what goes inside the brackets is the result from that division, or you could think about it as the other factor. If it's 5 times something, what is that other something? So either way, doesn't matter how you think about it, okay? If you're happy to do these divisions, I think that's a really nice way of figuring out what's left. Or if you've already written in your factors, okay, you can look at, well, what factor did I multiply 5 by to get my original answer? And that's the one that goes in the brackets. So take your pick. Okay, so we have a couple of redos here, guys. You know the drill. If you can, pause the video, have a crack at these questions yourself. We'll come back together in a couple of minutes when you're ready, see how you went. Pause now and I'll see you soon. And welcome back. Let's have a look at how you did. So, 6x plus 15. As usual, I like to start with my number factors first. The two numbers that times together give me 6. I've got 3 and 2. Two numbers that times together give me 15. 3 and 5. Right off the bat, I can spot a factor that's common. 3. Okay. So, good. I can also see that there's only a variable in the first term, not the second. So there's no common variable. So what we do is we put our highest common factor out the front, and then the result from the division, or in other words, 3 times what will give me 6x. That's what's going to go inside my bracket. So 3 times 2x is equal to 6x. I have a plus, so I'm going to plus. And then I need to say, well, 3 times what will give me 15? 3 times 5 is equal to 15. Now, if that's a little bit tricky, that's fine. You can add in some extra working. So I'll show you real quick another way with those divisions, some extra working. Okay, let's have a really quick look at that. So we've identified that 3 is my highest common factor. Hopefully we're okay with that. So I need to divide each term by my highest common factor. So 6, that's a 6. 6x divided by 3, well, that's 2x. So 2x is going to be the value that goes into the brackets. We do the same for the other term, which is 15. So 15 divided by 3 is equal to 5. And so this is the other term that goes inside the brackets. So we have a little therefore. Our factorised term, highest common factor goes out the front, and we put in those terms that we just worked out. Remembering that our problem had a plus, so our answer will also have a plus for now, until we get tricky common factors of negatives, but that's a good rule of thumb. Righto, we'll rush through this one since we explained that one pretty thoroughly. Numbers first, okay, so factors of 12, 6, 2, 4, and 3. Factors of 18, 6, 3, 9, 2. Looking for the highest one, 6. Good. I also need to have a look at my variables. There's variables in both terms this time. A and AB. Now, A is common. It is in both. So therefore, it is a common factor, and it's going out the front with the 6. So what times 6A will give me 12A? Well, 2 times 6A will give me 12A. And plus, what times 6A will give me? 18AB. Well, 3 times 6 will give me the 18. And I also need a B in there as well. Rightio, guys. A couple of you-dos. So I'll leave you to it. Pause the video. Come back in a couple of minutes. We'll compare our answers. See you soon. Okay, welcome back. Your answers should look something like this. Okay, and then the second one, I've got a 2D, 5C, plus 6. Hopefully that looked pretty good. Another couple of you do, guys. Okay. Again, give yourselves a few minutes. See how you go. We'll check our answers together in a minute or two. See you soon. Alright, let's have a look. So what I did, I again want to have a look at my number factors. So I have 3, 2, and again I need to be careful with this one, 6 and 1. Usually I don't consider those ones, but when I have a look at 12, I can see that I have 3 and 4 and 6 and 2. So sometimes what you'll see is if a factor is the number itself, okay, it can be a little bit funny. We do need to consider those, so always be on the lookout for that little tricky case. So our 6, our highest common factor, is going out the front. Let's have a look at our variables. Okay, there's an x in both. There's 2 x's in the first term, but there's only 1 in the second, so we can only put 1 x out the front. And then I would have to multiply 6x by x, multiply 6x by 2 to get my 12x. Okay, something really similar over here, guys. Factors of 36, so I have 6 and 6, 9 and 4, 12 and 3, couple of factors there, 12 and 2, 8 and 3, and you know what, I might stop it there because I can already see that 12 is going to be hard to beat. So my number factors there, okay, it's going to be 12, so I'll put a 12 out the front. And let's compare those variables, those letters again. So what letters are in both? Well, the first one, I have p squared, so there's 2p and 1q. And then in the second term, I have 1p and 2 q's. So if I think about that, it might write it out to help me see it a little bit better. PPQ and PQQ. So there is 1p and 1q, 1p and 1q in both. So that is common and it's going out the front. Filling in what would be left over. So what do we need to multiply 12pq by to have it equal 36pq squared? So, well, 3 times 12 is equal to 36. And then what letters haven't I included? Well, there's an extra p in the first term. What number times 12 gives me 24? Well, 2. And there's an extra q that I needed. Something like that, guys. And the rest, guys, completely here for you to do. Have a go, work through these. There's plenty there. So we should have plenty of opportunity to develop your skills, get really, really handy at this factorizing stuff. It's a very powerful tool that will continue to come in handy later on in your math career. Answers will be provided later on, not in this PowerPoint over here all day, but keep an eye out for those answers. I'll see you next time.
Same again, guys, more questions, practice. It's a skill that you need to drill so that it becomes semi-automatic, okay? Something that you can do with relative ease.